We're now going to look at how we solve higher degree polynomial equations by factoring. Things that are higher than an x squared, or an m squared, or a t squared. So the way we do that is we look at the problem that we have, 6x cubed minus x squared equals 2x. And so one thing we can do is to recognize GCFs. Well, before we do that, we always want to make it equal 0 when we're trying to factor a polynomial, so we can use that zero product rule. So we're going to move the 2x and get 6x cubed minus x squared minus 2x equals 0. Now I'm going to start with a GCF. And so the GCF between 6x cubed minus x squared and minus 2x is simply an x. And that's going to leave behind 6x squared minus x minus 2. Now, this is a nice trinomial that we know how to factor. 6 times minus 2 is minus 12. Minus 12 breaks down as negative 4 and positive 3. Divide both by that lead number, 6 again. Minus 4 over 6 becomes minus 2 over 3. 3 over 6 becomes positive 1 over 2. Notice that negative 2 times 1 is our negative 2. 3 times 2 is our positive 6. Number on bottom goes to the front. Number on top follows after. Now I have three different factors equal to 0. When does x equal 0? Well, when x is 0. When does 3x minus 2 equal 0? That's positive 2/3. And when does x plus 1 equal 0? That's when x is negative 1. So my three answers are the set 0, 2/3, and negative 1. Notice we started with an x cubed, and we ended up with three answers. That's not a coincidence. You will always find at most, the degree of the highest degree of what you're solving. Well, not every problem factors so nicely, or has the GCF the same. So what if instead we have minus m to the fourth plus 5m squared minus 4 equals 0? We've already got this equal to 0, but now we have this issue of having m to the fourth and m squared. It's still a trinomial though, and this is key. And notice that 4 is twice 2. 2 times 2 is 4. Since the lead power is twice as much as the middle power, and there's no powers on the last one, we can use this rule that allows us to multiply this out. And so what we can see is, let's let a new variable u equal m squared. Notice if I square both sides, what I do to one, I have to do the other. I get the m to the fourth. And so I can rewrite this whole problem as minus u squared plus 5u minus 4 equals 0. Well, we don't like this minus 1 in front of the u squared, so let's send through a minus sign to everything. Notice I applied it to the 0 as well. And so I'm really solving u squared minus 5u plus 4 equals 0. Factors of 4 that add up to minus 5 are minus 4 and minus 1. So u equals 4 and u equals 1, because 4 minus 4 is 0, and 1 minus 1 is 0. So as long as I make one of them 0, I'll get a true statement. However, we're not solving for u, we're solving for m. So this is really m squared equals 4 and m squared equals 1. Well, to solve this, we subtract the 4 over, recognize this is a perfect square, or a difference of squares rather. So m really equals negative 2, or m equals positive 2. Likewise, m squared minus 1 gives m plus 1 times m minus 1. So we get m equals negative 1 and m equals positive 1. And so my four answers are minus 2, minus 1, 1, and 2. Any of those four values makes this equation true. The last case that we're going to look at, suppose we have x cubed minus x squared minus 16x plus 16 equals 0. I have 4 this time. So remember, when we have 4, we group them throw our plus sign in. X cubed minus x squared has an x squared in common. That leaves behind x minus 1. Minus 16x and positive 16 has a minus 16 in common. Remember, we want to make the first one positive. That leaves behind an x minus 1. We factor out the x minus 1, and we're left with x squared minus 16 equals 0. X minus 1 can't factor any farther, but x squared minus 16 can. So we're left with x plus 4, x minus 4 equals 0. So this one gives us an x of 1, an x of minus 4, and an x of 4. So my final answer is the three answers. Again, notice we were looking for 3, minus 4, 1, and 4. That's our set. As long as I pick one of these three answers, I'll get a true equation.